For more than a century, physicists have been really interested in black holes, with the idea really taking off around 1916. These weird spots in space are some of the most fascinating things we know about. They're where super strong gravity meets stuff we just don't get. A black hole that might weigh 2 to 4 million times as much as our sun is still a big mystery out there. Even after tons of work for a while, we've gone from knowing next to nothing to figuring out some details, with even more being found lately. Someone named Kaku made a cool discovery that shows some surprising stuff about what's inside black holes. This might make us rethink what we've always thought and give us new ways to see these space blobs. This new info lets us look closer at stuff we might have missed before. Come check out this cool world of black holes and see what's hidden way out in space. First, what are black holes? Before we get into Kaku's new stuff, let's go over the basics again. Most of us kinda know what a black hole is, but some important things are still fuzzy. Back in 1916, Albert Einstein's big idea about general relativity said that black holes should exist. At the time, it was just a theory. It wasn't until about 50 years later that we found actual evidence that black holes are real things in space. This happened in the 1960s when people were checking out a star called X1, which gives off X-rays. They saw that the X-rays weren't just moving randomly, they were being pulled into something dense and invisible. This thing, which turned out to be a black hole, changed how we saw the universe. It was a huge deal because it proved that black holes weren't just in Einstein's head but were real, hard-to-find things that we should learn more about. After this discovery, scientists everywhere started trying to find out even more about black holes. They figured out that just our Milky Way galaxy might have around 100 million black holes. But because they're hard to spot, this is just a guess. Even though they're super hard to find, scientists think there are millions of these big things hiding in our galaxy, which makes it even more important to understand them. Let's get down to what gravity really is. Black holes have such strong gravity that anything that gets too close gets squeezed into a tiny point called a singularity, where the rules of physics don't work like we think they do. Basically, black holes are like giant space vacuum cleaners, sucking everything in. One of the scariest things about black holes is that if you fell into one, you'd get stretched out and squished into a singularity, your body ripped apart by the crazy gravity before you're totally destroyed. It's best to stay away, even though they're all over the place. Even though the closest black hole is almost 500 light-years away, it's still kinda worrying. In 2021, scientists did something amazing. They got the first clear picture of a black hole, the M87 black hole. It took a lot of nights taking pictures and putting them together to make one good image. As they got more data, they could see that black holes have 3 different layers. People usually think they're just empty holes, but the first layer, called the event horizon, is the point where nothing can escape. Once something crosses this line, it's gonna get sucked into the black hole. The second layer, the photon sphere, is where light gets trapped and can't get out because of the strong gravity. And then there's the singularity, where everything is squeezed into a super tiny point. It's a place where everything we know about reality falls apart and the laws of physics stop working. What's even cooler is that every black hole is different. They all have the same 3 layers, but they act differently, which makes them hard to study. Regular science stuff doesn't really work when you're trying to learn about black holes. Scientists have to find other ways, like looking at the radiation they give off or studying the gas and dust spinning around them. You can't just send a probe into a black hole because anything that crosses the event horizon is gonna get pulled into the singularity and crushed. So, we can't spend billions on probes that would just get destroyed without giving us any good info. That means researchers have to study black holes in 2 dimensions, even though they're 3-dimensional singularities. To make things even harder, no 2 black holes are exactly alike. When we study them, we have to remember that physics as we know it doesn't apply. Some ideas about where black holes come from say they might form when really big stars collapse. When a star runs out of fuel, it can't make enough energy to fight gravity, so it collapses into a black hole. If the star is big enough, this keeps happening until all the stuff becomes a singularity. To get a better understanding of black holes, NASA scientists looked at the middle of the universe, especially the M87 galaxy. They saw a crazy swirl of hydrogen gas spinning super fast, like 1.2 million miles per hour. The forces should have made this gas fly apart, but it stayed together, which means there must be something big in the middle, probably a black hole. This thing is thought to weigh up to 3 billion times as much as our sun. Another big idea came in 1963 from a mathematician named Royer, who used Einstein's ideas to explain how rotating black holes work. He said that instead of collapsing into a point, like people thought, a rotating black hole forms a thin, ring-like thing called the ergosphere. This spinning disk of stuff is important for understanding why the regular rules of physics don't work near black holes. Royer's idea also said there might be an Einstein-Rosen bridge, which is like a wormhole that could be a shortcut through space-time, connecting far-off parts of the universe or even different universes. To get what a wormhole is, you need to get space-time, which is how Einstein described it. Space-time is like a four-dimensional fabric that gets bent by things with mass. This bending makes gravity, which affects how other things move. Think of space-time like a piece of paper. If you fold the paper, you make a shortcut between 2 points. That shortcut is what a wormhole is, a way through space-time that could connect places almost instantly. Even though wormholes are just a theory and we haven't found any, they make sense based on general relativity. But wormholes are also unstable, so they would collapse really fast if they were made. Still, the idea of wormholes as a way to get to other parts of the universe or even different times has gotten physicists excited for years. One specific type of wormhole, called the CR wormhole, is really interesting. It was named after Royer, and theoretically, it could connect two far-off points in space-time, maybe even linking different universes or timelines. It would be cool to use wormholes for space or time travel, but there are big problems. Wormholes are supposed to be unstable, and the crazy radiation and forces around them would make it almost impossible to go through them safely. Some people say that Einstein's ideas, while good for understanding gravity, don't explain the quantum forces that control radiation and small particles. To really get black holes and wormholes, we need a new idea that combines gravity with quantum mechanics. This idea is often called the theory of everything, and many physicists, like M. Yakubu, have been trying to figure it out for years. One possibility is superstring theory, which says that small particles are actually tiny vibrating strings. This theory says that these strings make up the universe and can explain gravity and the stuff around black holes and wormholes. But superstring theory also needs extra dimensions of space-time that are so small we can't see them with the technology we have now. Even with the problems, trying to understand black holes, wormholes, and space-time keeps scientists excited because it could lead to big discoveries that change how we see the universe. To continue, the search for superstring theory and other theories to put the forces of nature together is hard, but it could teach us new things about what reality really is. These theories say that the universe has more than just the 3 dimensions of space and one of time that we know. They think there are more dimensions, but they're so small we can't see them directly with what we have now. But if they're real, they could help us understand black holes, wormholes, and the biggest mysteries of the cosmos. Superstring theory gives us a cool picture of the universe, saying that all stuff and forces are just tiny vibrating strings. These strings can vibrate differently, and each vibration is a different particle. Like a guitar string can make different notes, the basic particles of nature might be different patterns of these strings. If this is true, it would explain the basic forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, and it would also give us a different way to see how the universe is put together. This could answer some big questions in physics, like what dark matter and dark energy are. They make up most of the universe's mass and energy, but we don't really know what they are. Even though it sounds good, superstring theory hasn't been proven yet. One of the big problems is that the extra dimensions it talks about are so small we can't see them. We would need supersensitive instruments to find them. Even then, it might not be obvious. This makes superstring theory hard to test with regular science methods. But because it's so nice mathematically, it's one of the best ideas in theoretical physics. At the same time, scientists are also trying other ways to understand black holes better. For example, quantum gravity is another area where they're trying to combine quantum mechanics, which explains how small particles act, with the theory of general relativity, which explains how big things like planets, stars, and black holes act. They hope that by putting these two theories together, they can better understand how gravity works on a small scale and learn more about black holes and other things in space. The place where quantum mechanics and general relativity meet is really important when studying black holes because the conditions near a black hole's event horizon, where gravity is super strong, need a theory that can explain both quantum and relativistic effects. In fact, the inside of a black hole, where the singularity is one of the weirdest and most extreme places in the universe. The singularity is a point where space and time get so messed up that the usual rules of physics stop working. To understand what happens there, we need a theory that can combine quantum mechanics and general relativity. This has led to ideas like loop quantum gravity and other quantum gravity models, which try to fix these problems and give us a better picture of black holes. As we keep trying to figure out the mysteries of black holes, one thing is sure: the more we learn, the more we realize how much we still don't know. Black holes aren't just places where things get destroyed, they're also super complex and full of possibilities. Whether they're gateways to other dimensions, like some people think, or whether they hold the key to understanding space and time, black holes are still a really important thing to study. As our tools and theories get better, so will our understanding of these mysterious things. Looking ahead, the next big thing will be to get better at watching and studying black holes. One of the coolest things that's happened recently is gravitational wave astronomy. Gravitational waves are like ripples in space-time caused by big things moving around, like black holes crashing into each other. By finding and studying these waves, scientists can learn about how black holes and other things in space act in ways we couldn't before. Finding gravitational waves has already taught us a lot about black hole mergers, and we'll probably learn even more in the future. Another promising thing is using better telescopes and imaging techniques. The Event Horizon Telescope, EHT, which made the first picture of a black hole in the M87 galaxy, shows how new technology can help us see black holes. By using data from many radio telescopes around the world, the EHT was able to take a picture of the black hole's shadow, giving us a peek at one of the most mysterious things in the universe.